Hello, my name is Lindsay Drackenberg. This is for Chem 125, and this is the interactive advanced concept video. Today we will be doing an experiment using a balloon. I have Elmo here. It was from the Triplets I Nanny's birthday party, so extra special balloon. And then I have salt, and I also have pepper. And when we get to the experiment part, I don't have a plate up in my office, so I will dump it on this board, which we'll utilize as a plate. So before we get into the experiment itself, I want to briefly touch on your ions and then also charges, because that will impact the experiment we're about to do and kind of lay the groundwork for that. So I'm going to turn you over here. I apologize about the lighting. Starting with ions, those are atoms that are either positively or negatively charged. And charges are important to know as we learn this week in class and from our reading, because it depends how different elements interact with each other and how ions interact with each other, all that good stuff. As I have here, it shows that positive and negative charges are attracted to each other. So that means if I have a positive and I have a negative, they're going to connect together because they are attracted to each other. And by contrast, if I have a negative and a negative, they're going to bounce back. They aren't attracted to each other. So that is important to know for this experiment. So as I said, I have the balloon, and I kind of drew a diagram here of what is going to happen and what the experiment called for. So I have a balloon, and it doesn't really do much right now. So I have my pepper, and if I hang it over, nothing special happens. But as I will rub it on my head, it will get a buildup of a negative charge. And then I will, once I dump the salt and pepper together on my makeshift plate and hang it over, then we should see something happen. And that's where the question mark comes from, since we're doing an experiment. Either my salt will rise, my pepper will rise, or neither. We'll have to see. So before we do the actual experiment itself, let's talk briefly about our two elements that we have here. So we have salt, which is a combination of chloride and sodium. So we have our sodium up here, which is a positive charge. We know that from our periodic table, and it's in the alkaline metals. And then we have chloride, which is a negative charge, and that's a halogen. So as you can see, I wrote it out there, and it shows that it's NaCl, and that's a neutral. And it's neutral because we have one positive and one negative. Now, as we learned over here, they are attracted to each other, but they also cancel each other out, which makes it a neutral thing. And then we move over to pepper. Pepper is a bit more complicated in my opinion. It has a bunch of different elements, as you can see. So all the carbon, hydrogen, nitrogen, blah, 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 we can find those super easy on the periodic table. Flip it open and you can find it. You can find their atomic names and numbers and all that, and element symbols and all of that good stuff. But pepperine is not so easy to find, and that took some investigative work in terms of what is that. And upon doing that, I found that it is a combination of different elements, different compounds. So it is a bioactive compound, and it's an alkaloid. We haven't learned those yet, so I can't fully explain to you what that means, but I do know that is a synthetic compound, so it kind of depends what they mix in. We don't fully know that. There's many different things, many different possibilities, I guess is what I'm saying here. So, discounting the pepperine, we would have, as you can see here, a -2 charge. And that is based on looking at the periodic table. I have those two cancel each other out and then cancel one out, so that's the -2. But for pepperine, we don't know its charge because it's a combination of many different elements. So without counting the pepperine, this is what it would look like. If you have it written out, and 3. Okay. So we know this is for sure neutral, but pepper, we're not so sure because it depends what type of pepperine is in it. All right, so I think we are ready to do the experiment. So I will take some of my pepper, I'll there we go, angle it down. Take some of my pepper. Oh, that's a lot, that's okay. Dump it on, take my salt, dump it on. I will use my finger to kind of mix it up. Okay, it back in a pile. Okay, so as you can see, the pepper is right there. It's in a fun mix with the salt. So let me find Elmo. So I have our balloon. Again, right now, not doing anything. So bring it back. So I will rub it on my head, mess up the hair, but for the sake of science, that's okay. All right, and then before I do it, I'll bring you back over. Oh my goodness. Magic, also known as science. So I'm going to bring it up to the camera and you will see that this is pepper. So my pepper stuck to Elmo and my salt stayed down. Awesome. Okay, we'll set that over there. We'll clean that up later. Okay, so moving to the question mark, it's no longer a question mark, obviously, because we just did the experiment. So what we found is that the pepper, since the balloon had a negative charge, the pepper has a positive charge. Now that's different than what we found based on this, but again, since I said the pepperine, we don't fully know what's in it because it's a mixture of different things and can vary based on what's in it. If it's white pepper, if it's dark pepper, that does all matter. But yeah, it ended up being a positive charge, which means it was attracted to our negatively charged balloon. There's other reasons for that too. The salt is lighter than the pepper, so obviously, pepper is lighter than the salt, so that makes a difference with how it moves up and down. And then also I want to touch on polarized real quickly. That basically means that there's a mixture of positive and negative within the ion. And so we have more positive than more negative, so the positive will stick up to the balloon. So that's basically what happened with this, is that even though there might be some negative in here, it stuck up to the balloon, which allowed the positive to attract to the negatively charged Elmo balloon. So that was a success. Basically, in this lab, we talked about positively and negatively charged ions, what they do and how they are attracted, or in the salt's case, not attracted to each other. So thank you.